All right, we are into chapter 12 now. You're going to notice 12.4, Simplify Rational Expressions. Just a little bit about this section here and why I'm teaching to you, why it's important. This has to deal with fractions, rational, ratio, fractions. And what you're going to need to know how to do in this course is know how to reduce fractions appropriately, which is why I'm showing you guys this section right here. Anytime you guys see anything in an excluded value, you can just ignore that for the time being. That's not something you'll see that in algebra too, but we don't need that for the sake of geometry. So if you see these questions that say find an excluded value, you can just skip those or ignore that part of it. All right, so we're going to be putting things in what we call simplest form. The numerator and the denominator have no factors in common other than 1. So what that means is step number 1 is we're going to factor the numerator, which is the top of the fraction, and denominator, which is the bottom part of the fraction, if possible. And there are some things in here that students do wrong, and I'm going to try to demonstrate or show you those things. So here, this AC divided by BC. What we can do is we can reduce, so this isn't really factoring it, but it's putting it in terms of the factors. As long as you're multiplying, you can reduce this. And the reason why we can reduce that is C divided by C is equal to 1. So what this is really saying is A over B times 1, which is just A over B. So by reducing, we're just basically coming up with values that equal 1. In this case here, I'm going to factor the GCF, and the GCF here is 2. So you divide 2 out of the numerator, and I can divide a 3 out of the denominator. And now x plus 2 divided by x plus 2 equals 1. So this is just really 1, and you're left with 2/3. And that's the concept that we're going to be working with today. Now, there are many different types of examples. Take a look at this slide here. I got all of these for you guys, and I got all of these. You can see that there are many different types of problems that we're going to be reducing. So, take lots of notes. Take all the notes here, because they're all different. And when you get to the textbook, it's going to be a scattered assortment of problems. And in this class, you don't know what you're going to face, so you want to be able to do all of these skills. So the first one, I have r divided by 2 times r. Well, r divided by r, that's 1. There's not a 0 over 2. That is incorrect. R divided by r is 1, so there's 1 over 2. Right, so that's my first one. We have 5 times x over 5 times x plus 2. 5 divided by 5 is 1, so we have x over x plus 2. Now, let's talk about this. X over x plus 2. There are many students that go that, and they go 1 over 2. No. Mr. Drexler will cry if you do that. Okay? Because let's just take any number for x and plug it in. Let's say x equals 5. If I plug in a 5, we have 5 over 5 plus 2. That's 5 over 7. Does that equal 1 over 2? No. And I just picked a number. Okay? If you pick any number for these problems and you put in your original number, it's going to work. So let's put in a 5. Let's say r equals 5 here. I have 5 over 2 times 5. That's 5 over 10. 5 over 10 equals 1/2. Look at that. 1/2. Same thing. If you plug in a number into the original problem, you're going to get the same answer as if you plug it into what your answer is. So, I cannot stress this enough. You cannot reduce this x and this x. It's because of this plus sign here. The only time you're ever going to reduce something that has a plus or a minus in it is if it is being multiplied. So this is 5 times x plus 2 and 2 times x plus 2. X plus 2 divided by x plus 2. That is equal to 1, which is why we can do this. This equals 5 over 2. That's the only time. So, you'll hear me talk about that concept, that skill a lot. All right, for this letter C here, I'm going to factor out the GCF here. And the GCF out of the numerator is 6m squared. When I factor out 6m squared, I'm left with m minus 2. So we spent that section on factoring so you guys know how to do this. And then I have 18m squared. So if you want, you can write the 18 as 6 times 3 times m squared, and that might help you reduce the 6's. So the 6 is reduced, the m squared is reduced, and I'm left with m minus 2 over 3. Alright, this one right here, we have y over, and what I'm going to recommend is you always put the variable in the front. So if it's 7 minus y, I'm going to switch that around to negative y plus 7. Now again, do not do that. That's sad, you cannot do that. It's y over negative y plus 7. There's nothing to reduce there. So don't do this. Alright, let's go down here. There's an invisible box around here. I don't know where it is. Maybe it's gone now. There it is. Okay, I want to move this box somewhere down here. Okay. Let's take a look at a couple more examples. I have 4 times a times a times a. And it's kind of weird to write that out. Actually, I'm going to use 2 times 2. And the reason why I'm going to use 2 times 2 is because the bottom one is 2 times 11, and then you have a times a times a times a times a. So by putting it into expanded form, you can see those a's are all gone. They reduce to 1. The 2's reduce, and you have 2 over 11, and then you have a 1 to a to the 3rd power. Number 6. This one doesn't factor. It's already done. There's no reducing. Number 7. I'm going to factor out the GCF. 2s comes out of the top. S plus 4 is left over. You can factor 3 out of the bottom. S plus 4 is also left over. That works out really nicely. Those are gone. And we have 2s divided by 3. Nothing factors out of the numerator here. The denominator, we have GCF of 8x squared. So that leaves me with x plus 2. Now here I have an 8 and an 8. And the x squared is x times x, so one of the x's is reduced. Now again, there's still something on the top. It is a 1. Make sure you include that 1 there. When there's nothing left on the top, there's a 1. Alright, and then on the bottom we have x times x plus 2. There you go. So as you can see, really quickly, a lot of these problems are very different. You're going to have to practice them all. You may have to factor some of these. Like if you see a trinomial, let me do one more example. X squared plus 5x plus 6. And how about x squared plus 6x plus 8? So using what we learned yesterday, the top would be x plus 3 times x plus 2. And the bottom would be x plus 2 and x plus 4. So this is using what we just learned. Those reduce, and your answer is x plus 3 over x plus 4. So you may see a trinomial or two in which you have to factor the trinomials. So if you see that, don't be afraid of trinomials. Okay, that's day 1. I'm going to get back to you guys with day 2 where we see a few more examples.